Hi everyone. Today we're going to study some sample problems of quadrilaterals. Example 1. The angles of quadrilateral are in the ratio 3, 5, 9, 13. Find all the angles of the quadrilateral. Let x be the common ratio between the angles. Therefore, the angles will be 3x, 5x, 9x, and 13x respectively. We know that the sum of all interior angles of a quadrilateral is 360 degrees. Then we can write 3x plus 5x plus 9x plus 13x equals 360 degrees. If we simplify the left side, it becomes 30x equals right side 360 degrees. Then we divide this by 30 to get the value of x as 12 degrees. Let us now compute for the angles. Let's begin with the first, and that is 3x. This x is we derive as 12 degrees, so we have 3 times 12. So the first angle is 36 degrees. Second angle, 5x. So we have 5 times 12, and that is 60 degrees. Third angle, 9x. So we have 9 times 12 equals 108 degrees. Last angle, 13x. We have 13 times 12, and that will be 156 degrees. Example 2. If the diagonals of a parallelogram are equal, then show that it is a rectangle. Let ABCD be a parallelogram. To show that ABCD is a rectangle, we have to prove that one of its interior angles is 90 degrees. We see that in triangle ABC and triangle DCB, AB equals DC. We say that opposite sides of a parallelogram are equal. Then BC equals BC. That means the side BC is common to the two triangles. Then AC equals DB. And this is given in the problem. Now we conclude that the triangle ABC is congruent to triangle DCB for the reason of SSS congruence rule. Then we can conclude that angle ABC equals angle DCB. We say that corresponding parts of congruent triangles are congruent. Then we have angle ABC plus angle DCB equals 180 degrees. First, we see that AB is parallel to CD. And we know that the sum of the measures of angles on the same side of transversal is 180 degrees. In this equation, we say that the angle ABC equals angle DCB. So in the second equation here, we can substitute the value of angle ABC for the angle DCB. So we rewrite this equation as angle ABC plus angle ABC equals 180 degrees. We simplify the left side into 2 of angle ABC. Then we divide this by 2. So we get the angle ABC equals 90 degrees. Since ABCD is a parallelogram and one of its interior angles is 90 degrees, ABCD is a rectangle. Example 3. Show that if the diagonals of a quadrilateral bisect each other at right angles. Then it is a rhombus. This is the figure. Let ABCD be a quadrilateral whose diagonals AC and BD bisect each other at right angle. To prove ABCD a rhombus, we have to prove that ABCD is a parallelogram and all the sides of ABCD are equal. We see here now that in the triangle AOD and triangle COD, OA equals OC. We say that diagonals bisect each other. It's given in the problem. Then the angle AOD equals angle COD. Actually, both are right angles. It is given in the problem. Then OD equals OD. That means this OD is a side that is common to the two triangles. Therefore, we conclude that the triangle AOD is congruent to triangle COD by SAS congruence rule. Then we conclude that AD equals CD for the reason that corresponding parts of congruent triangles are congruent. This is equation 1. Similarly, it can be proved that AD equals AB and CD equals BC. Let this be equation 2. From equations 1 and 2, we combine them and we conclude that AB equals BC equals CD equals AD. Since opposite sides of quadrilateral ABCD are equal, it can be said that ABCD is a parallelogram. Since all sides of a parallelogram ABCD are equal, it can be said that ABCD is a rhombus.